There are many amazing places in our solar system, but one in particular stands out. It is Titan, Saturn's largest satellite, a world covered in oceans and rivers, but not made of water, and where another form of life may be lurking. This distant world, shrouded in a dense orange haze, beckons scientists and sci-fi fans with its unique chemistry and potential for the existence of something quite different from anything we know on Earth. So what makes Titan so special, and why do we think there might be life there? Titan's atmosphere, like Earth's, is mostly nitrogen, but that's where the similarities end. About 95% is nitrogen, but it is the remaining 5% that plays a key role in determining the appearance and chemical processes of this unique world. Hidden within this small but important volume are methane and other hydrocarbons, compounds made up of carbon and hydrogen. When exposed to the sun's ultraviolet radiation, these hydrocarbons break down and engage in complex chemical reactions to form a wide range of organic molecules. It is these molecules that give Titan its characteristic thick orange color, shrouding Saturn's satellite in a dense haze and creating conditions for a very unusual chemistry unlike anything we know on Earth. This chemical activity, although occurring at extremely low temperatures, is one of the key factors that make Titan so interesting to scientists investigating the possibility of extraterrestrial life. Perhaps the most surprising thing about Titan is the presence of seas, rivers and lakes, landscape elements that we are used to seeing on Earth, but they are not made of water, but of liquid methane and ethane. These hydrocarbons, which are liquid at extremely low temperatures, form entire hydrological systems. It rains on Titan, as it does on Earth, but instead of water, liquid methane rains from the sky. These methane rains carve channels in the rock-hard ice crust, creating bizarre canyons and valleys. The rivers, composed of liquid methane and ethane, then slowly but surely flow into vast seas located mostly in Titan's northern hemisphere. Scientists suggest that Titan has a closed methane cycle similar to the Earth's water cycle. Methane evaporates from the surface of seas and lakes, forms dense clouds in the atmosphere, then condenses and falls as rain, feeding the rivers and flowing back into the seas. Despite the incredibly low temperatures that prevail on Titan, there is an amazing and complex chemical activity going on constantly in its atmosphere. Under the influence of the sun's harsh ultraviolet radiation, the methane molecules present in the atmosphere undergo cleavage. This process leads to the formation of a wide variety of different organic compounds, from simple hydrocarbons to more complex molecules. These organic compounds, like cosmic dust, gradually settle on Titan's icy surface, accumulating and creating what are known as tholins, complex organic polymers that represent a kind of chemical broth potentially suitable for the origin of life. The composition and properties of these tholins are still a mystery to scientists and a subject of active research. Given the unique conditions prevailing on Titan, scientists are actively pursuing various hypotheses in an attempt to explain what form of life might exist there, if any. One of the most interesting hypotheses suggests the existence of a vast liquid ammonia ocean deep beneath Titan's thick icy crust. Unlike water, ammonia can remain in a liquid state even at much lower temperatures than water, making it a potentially suitable solvent for life in extreme cold. This subglacial ocean may be the most likely habitat for hypothetical Titanian organisms, where they could obtain the necessary energy and resources from the chemical reactions that occur in the ammonia environment. In addition to the ammonia ocean hypothesis, another, even more radical hypothesis suggests that life on Titan may be fundamentally different, based not on water but on liquid methane. Imagine microorganisms swimming not in water but in methane seas. To test this possibility, scientists have even developed a theoretical model of a cell whose membrane consists not of lipids, as on Earth, but of completely different molecules capable of preserving their structure and functioning in an environment of liquid methane. This hypothetical methane cell opens up completely new horizons in understanding the possibilities of life and its adaptation to extreme conditions. Imagine microorganisms swimming in Titan's methane lakes, absorbing some hydrocarbons and excreting others. Of course, these are just theoretical models, but they demonstrate that the existence of methane-based life is possible in principle. However, the existence of life on Titan presents a number of serious challenges. First of all, it is the extremely low temperatures prevailing on its surface. At -179 degrees Celsius, all chemical reactions are extremely slow, making it very difficult to metabolize the energy needed to sustain life. In addition, the amount of sunlight and therefore energy available to life on Titan is significantly less than on Earth. This can severely limit the complexity of organisms that might be able to exist in these harsh environments. To unravel the many mysteries of Titan and finally get an answer to the exciting question about the possibility of life there, NASA plans to realize an ambitious mission Dragonfly. This innovative vehicle, which is a sophisticated helicopter drone, will be able to travel significant distances on the surface of Titan, overcoming icy mountains and methane lakes. Dragonfly will collect soil and atmospheric samples, analyzing their chemical composition in search of signs of organic molecules and potential biomarkers. Of course, most scientists consider the possibility of multicellular life, much less intelligent life, to be extremely unlikely on Titan. However, let us get away from the rigors of science for a moment and imagine the most fantastic scenario. If complex life did evolve on Titan, what would it look like? Obviously, such organisms would have to have a completely unique and unimaginable biochemistry and physiology, quite different from anything we know about life on Earth. Instead of the oxygen we are accustomed to, they would probably have used other chemical elements for respiration, and their metabolism would have been based on hydrocarbons rather than water. To survive in the extreme cold, their bodies would have had to have a complex insulation system, perhaps consisting of several layers of organic materials that trap heat. And they would need special pigments or shielding structures to protect them from the harsh atmosphere and ultraviolet radiation. Perhaps these organisms would be capable of creating striking and complex structures reminiscent of terrestrial coral reefs, but composed of organic compounds dissolved in liquid methane, forming entire underwater cities in Titan's hydrocarbon seas. The discovery of life on Titan, no matter what form it takes, whether simple microorganisms floating in methane lakes or something more complex and exotic, would mark not just a scientific breakthrough, but one of the most fundamental and significant discoveries in human history. It will forever change our understanding of the very nature of life, demonstrating that it is not confined to the narrow confines of terrestrial conditions based on water and oxygen. Life on Titan will show that it can thrive in the most unexpected and extreme environments we could never have imagined. In cold hydrocarbon seas, under an orange haze, in conditions completely incompatible with what we have come to think of as essential to existence. Titan is a world that challenges our usual assumptions about biology, chemistry, and physics, forcing us to rethink the place of life in the universe. Its study raises profound philosophical questions about our own origins, evolution, and possible future, as well as whether we are alone in the universe, or whether life is far more common than we ever realized. The discovery of life on Titan will be a watershed moment in the history of science and culture, opening new horizons for exploration and inspiring future generations of scientists, explorers, and dreamers.